Hello, in this video I'm going to solve a problem for you on the topic of trigonometric identities. Let us read the problem together first. Prove the following identity. Sin x plus cosine x over sin x minus cosine x plus 2 cosine x squared minus 1 over cosine x squared times 1 minus tan x squared equals to 2 tan x over tan x minus 1. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. Okay, let us go to the board and solve the problem. So you see, I'm supposed to prove that the left-hand side is equal to the right-hand side. By having a look at the right-hand side, you see that everything is related to tangent of x here. On the other hand, on the left-hand side, I have a mixture of sine, cosine, and tangent. This might motivate us to write the left-hand side solely in terms of tangent, if possible, and then try to do some algebra with the hope that we can reach to the other side, which is only includes the tangent x. Okay, how can we do that? You need to have a little bit of experience here. So can I write this in terms of tangent? It's not hard. You see, I can divide everything in this fraction, its numerator and the denominator, simultaneously by cosine x. Yes? First of all, if I divide the numerator and the denominator by something, cosine x in this case, I am not changing it because I'm rescaling the fraction. So the value of the fraction remains unchanged. But it will be immediately written in terms of tangent x in this case. Let us see why. I divide the numerator by cosine. There are two terms in the numerator, so I have to divide each one of them individually by cosine. When I divide this by cosine, it gives me tangent x, because sine over cosine is tangent, plus, if I divide cosine by cosine, it becomes 1. And the denominator, sine x over cosine x, becomes tangent x again, minus cosine x over cosine x is just 1. So what is happening here? So this fraction is equal to this fraction, but the good point about this is, now in this new form, it is expressed only in terms of tangent of x, which is good because I want to reach to the right-hand side. What can I do here? I can do the same thing, but I can do similar thing here. I want to divide everything by cosine x squared, okay? So I divide the numerator by cosine x squared, but there are two terms involved in the numerator. One of them is the first one. When I divide it by cosine x squared, this is gone, so what is left for me is just 2. But when I divide this by cosine x squared, so this is just 1 over cosine x squared. But in the denominator, I have the product of two numbers. So if for example, if you have a times b, and you want to divide this by c, this is one way of doing it. Or you can write a over c multiplied by b, that's also correct. You can write it as a times b over c. So if you divide a product by a number, you can do it like this. You can divide the first factor by the number and multiply the fraction that you get by the second factor. Or you can keep the first factor as it is and multiply it by the division of the second factor of that number. But not both. Because I have seen some students make some mistakes when you divide this. If you write a over c multiplied by b over c, then it would be wrong. Because the right-hand side, a over c times b over c, if you do it, it becomes ab, that is correct. But it becomes c times c, which is c squared, and that is not correct. Okay. So what I do, I divide the denominator by cosine x squared as well. Yes? So when I divide that, I take this away, and this is left. So this becomes 1 minus tan x squared. So I divide the whole expression by this. That one is gone, this is left. So far, it is promising, but the only problem is existence of this 1 over cosine x. Because as I told you, my goal is to write everything in terms of tangent, but this one is a little bit problematic. But it will be solved if you remember that this is also a famous identity in trigonometry. In trigonometry, yes. What is that? So, for example, you know that sine x squared plus cosine x squared is equal to 1. So if I divide everything by cosine x squared, what will happen? If I divide this by cosine x squared, it becomes tan x squared. If I divide this by cosine x squared, it becomes 1. And if I this by cosine x squared, it becomes exactly the combination that I need, meaning 1 over cosine x squared. So this means that this expression can also be written in terms of tangent of x using this formula. So this I will continue. So I would write here the left-hand side is equal to, so far, I copy and paste this once more. Yes, plus the denominator, I keep it as it is. But for the numerator, I copy and paste 2, but instead of 1 over cosine x squared, I put this combination. But there is a negative sign behind this expression, which will be the negative sign behind the whole combination. So this means that this negative sign will go for tan x squared as well as 1. So it becomes negative tan x squared, but negative 1. Okay, but I can actually simplify this. So I copy and paste once more this part. Plus 2 minus 1 is 1, and minus tan x squared divided by 1 minus tan x squared. So that's very interesting now. You see what happens? It means that the numerator and the denominators are exactly the same, so this fraction becomes just simply 1. So this becomes tan x plus 1 over tan x minus 1 plus 1. And then I want to combine these two. So I have to write the common fraction, the common denominator. So let me just write it like this: tan x plus 1, tan x minus 1. I want to write 1 in a form of a fraction whose denominator is exactly this, so that I have the common denominators. So that is easy. Then it becomes tan x minus 1. I have to write tan x minus 1 as well. So tan x minus 1 over tan x minus 1 is exactly 1. So I haven't changed anything on the one hand. On the other hand, it is useful because I have the same denominators here. So this means that I can take the common denominator, which is tan x plus 1, and I can simply add the numerators. So, but look, tan x added to this tan x gives me 2 tan x, and then 1 plus minus 1 is 0. So I am left with this one. But that's exactly the right-hand side. So this becomes the right-hand side. So I started from the left-hand side, and I was able to do the calculations and reach the right-hand side. But that is extremely important to realize, that in proving identities, you should have some strategy, because just blind calculations usually doesn't work. Okay? So you see, when I wanted to solve that problem, so the naive way is usually to turn tangent to sine and cosine. It's still possible. You can work it out yourself. So if you want, we can just solve that problem using this method. I'm not saying that is wrong, but I would say this is more efficient. So what I did, I saw that, okay, this is a mixture of sine, cosine, and tangent. On the right-hand side, I have only tangent. So it motivated me to see if that is possible for me to write everything on the left-hand side in terms of tangent x only. I was able to do it, and then I was able to solve the problem. But if you don't want to do it, might be you start doing this. I will write the left-hand side. So for the time being, let me keep sine x plus cosine x as it is. I have sine x minus cosine x. That's also possible, by the way. So here, 2 cosine x squared minus 1. But I multiply cosine x squared inside. So cosine x squared times 1 is cosine x squared. But what happens if I multiply cosine x squared into the second term? Okay, so tan x squared is nothing except sine squared x cosine x squared. This is tan x squared, and I multiply it by cosine x squared, which will cancel that one, and I will be left with minus sine x squared. So this becomes minus sine x squared. That's also correct. It's a little bit deviation from the strategy because you want to write everything in terms of tangent, but actually you did the opposite. You just got rid of the only tangent that you had here, but I think still it would work if you know what to do. So what should I do? I have to take the common denominator between these two. So what I do, I write it as sine x plus cosine x over sine x minus cosine x. And then instead of writing plus, I write minus 2 cosine x squared minus 1. I copied and pasted the numerator. But this minus sign that I pulled out will swap these two terms. And then sine x squared comes first, minus cosine x squared. But then I can use the conjugate rule to factorize it. So I factorize it as sine x minus cosine x times sine x plus cosine x. And then between these two, the second one is my common denominator. So what I do, I will just write it as sine x minus cosine x times sine x plus cosine x. Yes? And then this one, I have to rescale this one so that the denominator be this. So I have to multiply this by that expression. So that would be exactly the same one in the numerator. This becomes sine x plus cosine x to power 2. And then minus the whole expression, because that one is exactly the same denominator. So I don't need to rescale it at all. But this minus sign, be careful, goes not only for the first one, but also for the second one. This becomes minus 2 cosine x squared plus 1. Okay? It seems that it is not working, but let us try to continue simplification. Okay, so what I do, I expand that. The first one squared is sine x squared, 2 times the first one times the second one, 2 sine x cosine x, plus the second one squared, which is cosine x squared, and then minus 2 cosine x squared plus 1. And in the denominator, I copy and paste what is there. Still, I can continue to simplify the numerator a little bit more. Okay, so first let me take off this slide so that you can see what is going on. Okay, so here I have sine x squared and cosine x squared together, it becomes 1. There is another 1 here, so 1 and this one and that one in total becomes 2. So I have 2, so let me write it here. So this becomes 2 sine x squared, cosine x squared 1, another 1 there is 2. And then I have this term and that term. Okay? That term. So this is 2 sine x cosine x minus 2 cosine x squared. This one. And minus 2 cosine x squared. Divided by, I copy and paste the denominator. Okay, but what I'm supposed to do now? I see a factor of 2 here. I factor a 2 out, and that is promising a little bit because you see on the right hand side you have a factor of 2 involved. That is good actually. So what I do, I factor a 2 out, and then this becomes 1. This becomes minus cosine x squared. If you don't mind, I intentionally write these two next to each other. And when I pull 2 out, there is only sine x cosine x left here. And then I divide it by the same expression once more. But this is also famous in trigonometry, yes? 1 minus cosine x squared is sine x squared. Why? Because of this rule. Sine x squared plus cosine x squared is 1. So if I move this to the other side, 1 minus cosine x squared is nothing except sine squared. So instead of that one, I can simply write sine x squared plus sine x cosine x and then divided by this expression. Okay, then what can I do? Then fortunately you see then there is a factor of sine x in common. I can pull that one out. So I have a 2, I pull a sine x out. From the first term, 1 sine x is left. From the second term, plus cosine x is left. And then in the denominator, I have sine x minus cosine x multiplied by sine x plus cosine x. And then what happens, I can take that and that away. And then what is left is 2 sine x over sine x minus cosine x. So I actually simplified the expression quite a lot. So I started from the left-hand side and simplified this expression, and I got here. Then I want to actually to finalize the problem and reach here. So might be you cannot see what you're supposed to do. One way to do is to go to the right-hand side, simplify the right-hand side as well, and compare it with the final result here to see that they match, and that is quite okay. But that's also a simple way to do it. So what I'm supposed to do, I want to write this expression in terms of tangent x. From the experience you got there, probably you can guess what I'm supposed to do. I rescale this fraction by dividing everything by cosine x. Why this is useful? Because if I divide the numerator by cosine x, it gives me 2 tangent x. And if I divide the denominator, there are 2 terms involved. If I divide this one by cosine x, it gives me tangent x once more. Minus, if I divide cosine by cosine, it becomes 1. So I actually rescale the whole fraction by cosine x here at the very end. And then I again reach to the right-hand side. But I hope that you agree with me. So if you find a good trick that will actually makes the problem simpler to solve. But still, if you are doing things correctly, that's the good point and the power of mathematics. If you are doing things consistently, you will definitely get the correct answer at the end. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.